138 product of array except self. Given an integer array nums, return an array answer such that answer I is equal to the product of all elements of nums except nums at index I. The product of any prefix or suffix nums is guaranteed to fit in 32-bit integer, and we should do it in a linear time complexity without using division operation. So let's see the first example. The first example, the array is given to us is 1, 2, 3, 4, and we are going to get the product of all the elements except that element itself. So what does it mean? So I start from index 0. We have 1 in it. We just don't do anything with 1, but we get the multiply of 2, 3, and 4, which is going to be 24. And the second number is 2. We just ignore this and get multiply of 1, 3, and 4. For 3, we just ignore this and we get the multiply of 1, 2, and 4 and put it in this index, in the second index. And in the third index, what we are going to do, we ignore 4 and we get the multiply of 1, 2, and 3 and we put it here, right? And as you see, this is the second example because we have 0 in here. So 0 multiply any number is going to be 0. So the only number that we are going to get from multiplying these numbers other than 0 is going to be the index that we have 0 in it. And let's see how we can solve this problem. What we can do, we should do it in linear time complexity, right? One way to do that, if we didn't have this constraint, was the brute force one. We could start to have a for loop starting from the index 0, and we could have another inner loop to do the multiplication, like doing the to get the product value of these numbers. But we should do it in linear time complexity. Let's go through one example and see how we are going to solve this problem. So let's say if we have 1, 2, 3, 4, and we are going to get the multiply of all the elements except that index itself. So what we can do is we can start to multiply these numbers from left to right and from right to left, and then multiply the left and right array. So what I'm going to have a left array and I'm going to have a right array, right? I'm going to have two arrays, and then at the end I'm going to return multiply of left and right. This is the answer that I'm going to return, right? So how are we going to generate array left? First thing to remember is this array is going to be the length of this array is going to be equal to the length of nums. So for this example, the length is 4, so we are going to have a new array called left length 4. How we are going to do that? We are going to, always for left, we are going to have 1 in left, and I'm going to multiply this with the first item that I have here, and I append it to this list. So how is it going to happen? So 1 multiply 1 is going to be 1. I'm going to append it here. And 1 multiply 2 is going to be 2. I'm going to append it here. And 2 multiply 3 is going to be 6. I'm going to append it here. Am I going to multiply 6 and 4? No, because length of this array, we have this limit here. The length of this array is equal to length of nums. So it is 4, this is 4, we just stop it here. How about for the right one? For the right one, we are going to have an array of all elements 1 here. So I will start because we go from right to left. So we cannot use append, which is constant time complexity, and I don't want to use insert because of the linear time complexity. So I'm going to have a list of ones, and I'm going to start from the end of the array. So I will say 1 multiply 4 is going to be 4. I'm going to put it here. 4 multiply 3 is going to be 12. I'm going to put it here. 12 multiply 2 is going to be 24. And because we are done with this list, we are not going to multiply to 24 by 1, right? So we leave it. And now I get the multiplication of these two. So 1 multiply 24 is going to be 24. 1 multiply 12 is going to be 12. 2 multiply 4 is going to be 8. And 6 multiply 1 is going to be 6. And as you see, this number exactly is, this list is exactly equal to the output that we have here. So how can we code this? To code this, we are going to have one while loop for left, we are going to have a one while loop for right, and we are going to have another while loop for the result, right? And let's make the left one first. For the left one, we are going to have a list left, and we put 1 in it, right? And then we say we start to we are going to have I and J. We are going to have while loop, and they both start from index 0. We are going to say while J is smaller than the length of the nums minus 1. What we are going to do, I'm going to say left dot append is going to be nums I and multiply left J, right? And then I add 1 to I and I add 1 to J. There we go. We have made the left array. Now we need to make the right array. For that, we are going to traverse the list from the end, right? So I need to have a right list, and as I said, we are going to have 1 in it, so length of nums. And then I'm going to say I and J are going to be equal to length of nums minus 1 and length of right minus 1, right? For while we have J bigger than 0, we are going to say right. We need to put it one step backward, right? J minus 1 is going to be nums at index I multiply right at index J, right? And we move these two one step backward. There we go. We have our left and right ready, and now we are going to say for I in range length left, I'm going to use the left one and as the result. I'm not going to create a new list. You can do that too, but I'm just like saving a little bit of space. So for J, it's going to be left at I multiply right at I. And finally, we are going to return left. So the time complexity for this is going to be linear. And